Hey, physics class. So let's go to our next part. Did some combining of simple vectors, basically either both going east and west or both going north and south. Let's change that a little and get combining vectors in two directions. What do I mean by that? Let's go with an example. Let's say that Mr. Westwood traveled, so let's go this way. There's me in a forest. I travel 12 meters east. And then I see something shiny on the ground and kind of beside me, so I travel, let's say, 5 meters south. Okay? So now these vectors not exactly in the same direction. I can't just minus or add them because I want to know, again, what is the resulting vector? How far away from the beginning am I? Well, basically, if we draw this, this looks like something we might have seen already now. This looks like a triangle, and so you've probably done these kind of questions already in the sense of when we do trig. Okay, so we're going to have to find two things here. One, the magnitude, like what's the distance from there to there, and as well, we're going to have to find that angle. Okay, so we're going to have to use some Pythagoras to find the actual magnitude, which means to find the actual distance from here to there. You're going to go your a squared plus b squared equals c squared. So let's do that now. A squared plus b squared equals c squared. So we have 12 squared plus 5 squared equals c squared. 144 plus 144 plus 25 equals c squared. This gives us 169, okay, equals c squared. Now, that squared's still there, so square root. 169 square root should be exactly 13, so c equals 13. So basically our magnitude, how far, if I go 12 this way and then 5 down, this should be exactly 13. So 13 meters is just our magnitude. Okay, and that's, I think you guys will have no problem with that. You've done that before, no real issues here. Okay, that angle sometimes gets a little tricky for some students. So how do I do that angle? Well, let's put up a little more of our trig function here. These will never go away. So, I'm trying to find an angle. What sides do I have? I have my opposite. I have my adjacent. Which means I need to go tan. All right. Now, here's the formula that we always use. Here's the formula that I'm going to put into the formula sheet. Okay, it looks like this. To find an angle, okay, find an angle, you're going to go tan inverse, okay, of y over x. Okay, so there's a little formula. To get the actual angle, you're going to go inverse tan, okay, on your calculator you have that little inverse button, of y over x. Now what the heck does y over x actually mean? Well, if you guys think of a graph like this, you have your y-axis and your x-axis. All right? Your y-axis is always going up and down. So basically for vectors, anything that is going north or south is going to be your y-axis. South we usually say is negative, north positive, and x, again, x is your east and west movement. So in this case, here is your y, here is your x. All right? So let's actually figure this out. Let's figure out what the angle is that this person would technically travel at if they just went from straight there to there. All right, so we're going to keep it over here. We're going to go tan negative 1 of 5 over 12. Now let me get my handy dandy calculator. Turning on. 5 divided by 12. 0.416. So this equals tan negative 1 of 0.416. So now if I actually go inverse tan, 0.416, I get 22.6, I'm going to round it, 22.6 degrees. Okay, and actually, let me rephrase that. For the angle, I always want you to go like round to just a full number, okay? Because if you've ever had a protractor, if you try and find a decimal of an angle, it's impossible. So we're always going to actually round to the whole number. So here I have 22.6, so 23. 23 degrees is my answer. So our angle here is 23 degrees. So basically, what we would say here is they went 13 meters at an angle of 23 degrees. All right, so that's how we put together two different direction vectors. We had one that was going kind of in our x direction, one that was going in our y-axis direction, and that's how we put it together. We need to be able to find what angle as well as what magnitude we went in there. All right? Sounds good. Thanks, class.